Hello students, the next part of this topic, the mechanical properties of fluids is surface tension, but I am discussing this as a separate topic. Surface tension is defined as the force acting per unit length on the surface of the liquid. The surface tension appears, surface as the name indicates, tension is force. Force on the liquid molecules on the surface of the liquid is called as a surface tension. If you take any liquid in the container, there is a force attracting the adjacent liquid molecules. On the surface only we are discussing here surface tension. Viscosity is related throughout the material. Elasticity is also throughout the material. Elasticity, elastic property, surface tension, viscous forces all are related to the molecular force of attraction or atomic force of attraction. But surface tension is only for the surface molecules we are discussing. But in these adjacent molecules there is a force of attraction. So any light body if you are putting it cannot sink into the liquid. Light body means it cannot be very light body. It cannot sink into the liquid even though its density is more than the density of the liquids. That happens when you take the steel needle. Steel density is more than the water, but it won't sink if you gently put on the surface. Steel needles, steel blades also float on the surface by dipping the surface. If they have to sink inside, the distance of the molecule should change. If you disturb the molecule, then that object can sink into the surface, into the liquids. So between this adjacent molecule force is present, that force is called as a surface tension. If you take the liquid surface, imagine a line if you take but any molecules are spreading overall, for this line of length L, the force acting on both sides, attracting both side directions, the force acting per unit length of this length 1 unit is called as the surface tension. That is the definition. Units are Newton per meter or AC is Dyne per centimeters. It is also defined as a work done to increase the surface area by 1 unit or surface, whatever the energy is there for the surface molecules is called as the surface energy. The surface molecules energy is called surface energy. It is also equal to work done. The surface is also equal to surface energy per unit area or surface work done to increase the area by 1 unit. If a single area of taken means area is formed means you can take as the initial area as 0, final area you have to take as A only. So units can be Newton per meters or joule per square meters. Dimension formula is same. You will get a dimension formula of the surface tension. Surface tension dimension formula is nothing but equal to force by length. Surface tension symbol can be taken as S or T. So surface tension is nothing but equal to force per unit length. Force dimension formula is mLT minus 2 by L. L cancels. So what you get is ml0 T minus 2. Even though the formula L is present, but in the surface tension dimension formula L is not there. You can L to the power of 0 is 1. So you can simply write as LT minus 2. Dimension formula also important for the surface tension. Next is the shape of the liquid. So why the liquid drops always take this spherical shape? Because the surface molecules have the experience of force inwards by other molecules. If you take any liquid surface, every molecule on the liquid attracts other molecule up to some particular distance. Taking that distance as a radius and you take a sphere, that sphere is called as a sphere of influence. The sphere of influence is in the order of nanometers to 10 to the power of minus angstroms. You can take it also approximately 10 to the power of minus 10 meters or 1 angstroms approximately we can take. And this is called the molecular force of attraction. Up to the range is called as a molecular range, and getting this range is a sphere, which is called the sphere of influence. So if you take this sphere of influence of the surface molecules, if you have taken many molecules on this, you can draw the spheres around these molecules. Up to this radius, you take the thickness. So this is called as a surface film. This is the order of 1 angstrom units. All molecules near the surface experience force downward. These are molecules. Experience force downwards. Molecules inside the liquid have surrounded by the other molecules in all directions. Equal number left, right, and top, bottom. So the resultant force is 0. So molecules inside the liquid do not try to move. We are not discussing here Brownian motion. That is a different case where the molecules move with the temperature present randomly. That is a different case. We are discussing only because the molecular force of attraction. Molecules inside will not experience any force. The resultant force is 0. But molecules near the surface up to the distance equal to molecular range. That is this soap film or the surface film up to that thickness. Means thickness is equals to 1 angstrom. Up to that the molecules which are present within the surface, they experience resultant force downwards because within this sphere of influence more molecules are present at the bottom than at the top. Due to the reason every molecule on the surface try to go into the liquid, the result is the surface takes spherical shape. Why only spherical shape? Because the sphere has a minimum surface area, means minimum molecules will be there on the surface. Maximum molecules try to go inward. Due to that reason, all molecules go inward, leaving the surface having the minimum surface area. So we take the spherical shape. Surface area is minimum in 3 dimensions for the sphere, in 2 dimensions for a circle. So inside the pressure what happens is increases. inside the outside pressure is the atmospheric pressure. Inside pressure is more than the atmospheric pressure you will find because of this molecular force of attraction. So total pressure inside is nothing but equal to this atmospheric pressure. Because of this liquid molecules extra pressure you will get is called as the surface tension pressure is nothing but equal to 2T by R. This is for one surface you take liquid drops. This is called as the liquid drops. The total pressure inside is nothing but equal to P naught plus 2T by R. If you take excess pressure means P minus P naught. It is the extra pressure only because surface means that is equal to 2T by R. R is the radius of the drop here. Liquid drops take this pressure because of this surface tension property. If you take the bubbles, there are two types of bubbles, air bubble and soap bubble. But here is soap bubbles. Soap bubbles are the two surfaces, inner surface and outer surface. Here air will be there, outside also air is there, but very thin molecular layer will be present as the surface, and in the inner surface, outer surface almost equal, thickness is negligible. So radius you take the same inside and outside. For this case, this is called the excess pressure delta P is equal to T by R. But here total pressure is P naught plus 4T by R. This 4T because of the two surfaces. So excess pressure becomes equal to P minus P naught is nothing but equal to 4T by R. For two surfaces 4T by R. For single surface we have the 2T by R as the excess pressure. But in case if you take the air bubbles are formed inside the water. Air bubble is formed at depth equal to H if you have taken outside atmosphere is P naught. Here air bubble has only single surface. So if you take the air bubble at depth H formed, the excess pressure is nothing but equal to inside pressure has to balance the surface tension pressure. That but single surface is one surface only means 2T by R. But two pressures are present, atmospheric pressure and also pressure due to the liquid of density dl, which is nothing but equal to HdG value. So total pressure is nothing but equal to P naught plus HdG of liquid plus 2T by R. So this whole thing if you take it in what this is going to be excess pressure only. So delta P is nothing but equal to 2T by R. Delta P is supposed to be equal to P minus P naught minus HdG. This is nothing but equal to excess pressure. Next, the surface tension is also defined as work per increase area by 1 unit you can take. So this is 22nd problem. Take this 22nd problem. Find the work done to increase the radius of the soap bubble from 4 cm to 5 cm. The surface tension of the liquid is given as 25 × 10⁻³ Newton per meter. Surface tension is also we can take the force per length or work by area. When you talk about the energies, you use this relationship work by area or energy by area. Work is equals to energy or surface energy also is called as. So work done to increase the area. If you take the straw, soap bubble, if you take the wet straw and insert into this and blow the air, the bubble size increases. When bubble size increases, what is the work done to increase the area by 1 unit? Here surface is work by area, work equal to delta into T. Work equal to delta into T. But it is a liquid drop in single surface. But it is not a liquid drop, it is a soap bubble. Soap bubble means two surfaces will be there. So what I get here is area is nothing but equal to 4 pi r square. Soap bubble area is nothing but equal to 4 pi r square is the surface area for the soap bubble into 2, sorry. This is for one surface into 2 means 8 pi r square you get the surface area. But surface area is changing means delta A. Changing means delta equal to delta r square equal. So don't take r2 minus r1 whole square, you take the r2 square minus r1 square. The difference in the work delta W actually it is 8 pi into r2 square minus r1 square into T surface tension. Substitute the values of r2 and r1. r2 is 5 centimeters, r1 is 4 centimeters. Centimeters means 5 × 10⁻², here is 5 × 10⁻² comes. Centimeter square is there. So 10⁻² square means 10⁻⁴ comes. So 5 square minus 4 square 10⁻⁴. This is the conversion of units. This is 8 by 8 pi and surface is 25 minus 3. The result is 5652 in 10⁻⁷ joules. You can change the decimal point position and the power will change on this. If it is a liquid drop area is nothing but equal to 4 pi r square per sphere. Single surface area. For soap bubble means two surface area. Next problem is a capillary rise method. Capillus is a small narrow pipe having the radius equal to the air size diameter. So you find a radius, very narrow pipe kept in the liquid. What happens here is there are two types of forces within the molecules. We call it the cohesive force. Another one is called as the adhesive force. In the case of the cohesive forces, the distribution is similar and the force with a similar type of molecules is the cohesive force. The force with the different type of molecules is called as adhesive force. Force with the water molecule and water molecule is coercive. Force with the water molecule and this glass tube and container is called as adhesive force. Gum sticks the paper because of the adhesion, means adhesive forces. So in this case, which force is dominating is important for us. If coercive forces dominates, the liquid will not rise in the capillary tube. If you take the mercury, in this case of the water glass. If you take the mercury, Hg and glass. If you take the mercury does not stick to the glass. If you try to retain its own coercive force, molecular force is very strong for mercury, and mercury retains its original shape. Every liquid original shape is a spherical shape because of the force of attraction. So liquid level will not rise, it falls. This is surprising. It depresses compared to the container liquid. If you insert the tube, capillary tube like a straw, this is going to be below the surface area, means the height is taken as a minus h. The angle between this liquid surface, tangible liquid surface, and glass solid inside the liquid, this is called as a angle of contact. The angle of contact theta for this mercury is more than 90 degrees, called as an obtuse angle. For the water and glass, the angle of contact is less than 90 degrees. If you take the same glass rod, if you insert it to the water, the liquid level will rise like this. So tangibly into the liquid, the theta is less than 90 degrees. This is called as an acute angle. So for water, glass, it is acute angle. For the glass and mercury, it is obtuse angle more than 90 degrees. Does not stick to the glass. This value is 140 degrees. You get equal to 140 approximately degrees for the mercury and glass. For silver and glass, the theta equal to 0 degrees. The level never rises, never falls. Level will be equal in both the cases. So in this case, for the liquid which is going to the glass, the theta is approximately 0. And the formula for the surface tension for this capillary rise method is given as surface tension equal to Hrd by 2 constant. D is the density of the liquid, R is the radius, H is the height, G is the acceleration to gravity, and theta is the angle of contact. For water glass, theta is 0. If they give the rising means, automatically it cos 0 equal to 1 only formula you have to use. Most of the cases, for case which liquid with the glasses or solids, cos 0 is 1. So Hrd by 2 we have to take. This is approximate formula actually because this is called the meniscus. Meniscus is a concave shape for the liquids which with the glass. So if you take the mercury, the liquid is convex system. So you pressure difference, if you want to take note, this pressure is P atmosphere pressure, this pressure is inside. Inside pressure is more than outside pressure here if you take the convex surface. But the concave surface if you have taken for the water cases, the P naught is more than P we have to take. And what is the delta P for single surface? It is equal to 2T by R. The pressure not by P, what are the pressure here and here? Pressure difference in the meniscus. Meniscus means a crescent shape, moon shape it is called. Is equal to 2T by R. Pressure difference. Next, come back to this problem. We are given the surface tension, Newton per meter, and radius is given. For the capillary tube in millimeters, 70 meters, in 10 to the power minus 3 meters. Height rising you are asked to find out. So surface tension value is also given for you. Substitute the values and you get H value. H is equal to 2T by R dg because 0 is 1. The substitution will give the value equal to 28 into the power minus 3 meters. But options are given centimeters. You get this is 28 millimeters, which is equal to 2.8 centimeters. Same in this formulas will be asked generally. HR relationship. Same liquid you have taken. Then in that case, all same liquid means theta T constant, theta is also constant, dg is also constant. So H is inversely proportional to R. If R decreases, H increases, and HR graph is rectangle hyperbolic. Take HR or x or y doesn't matter. It's going to be rectangle hyperbolic. Graph you will get. And R, there will be the ratios of the radii, and we are asked to find out the H ratios. H1 by H2 equal to R2 by R1. Next, if you are taking onto the moon, if you take onto the moon, the G will be less. If G is G by 6, you will get. G is equal to G on the moon is G on the moon is equals to G on Earth by 6. Another thing is for mercury and different glasses, liquids, if they give the theta 1, theta 2 means ratios, you can, they will ask problems, you can work out that easily. And what if you cut the glass? Height rise is for example 10 centimeters. I am cutting the glass to 5 centimeters. What happens? Does the liquid overflow? Means never. The liquid never overflows. Liquid goes to the topmost point, but at this meniscus, the angle of contact changes. Is the angle of contact theta change? That means surface will be modified. It will have the more radius. This is the spherical radius. If the sufficient length is there, then you will find this meniscus forming the perfect sphere inside itself. This radius. This radius will get. But otherwise what happens is the meniscus will modify such that this actual supposed to be radius, it will shift the radius, angle of contact will changes. That means it forms a different radius. R by cos theta remains constant. In such case, what it is, R by cos theta is constant. If you're taking the height, no, this h replaced with L, and L by cos theta is equals to constant. H you have to replace with the length. After this maximum length is L you have to take it as, and different length you have to take means that L1 L2 you have to take it up by L by cos theta is equals to constant, and the theta value changes. R is the radius of the capillary tube. If height is sufficient means this R is also radius of the capillary tube, R is also equal to radius of that meniscus, radius of curvature of the meniscus. In case if you bend that capillary tube, then what happens? If you bend the capillary tube, what remains constant is this height changes. This is the length of the column, this is the vertical height. What remains constant is as you bend. If you bend it like this, the component of the weight of the liquid acts on the walls of the tube. To that reason, L increases. When L increases, but height remains constant. That means whatever h you have taken on, that h becomes equal to L you have taken. L by theta, which theta is equals to that you will check up in the notes, so you will get the answers. Diagrams are there, you check up. The problems will not be there, formula only will be asked. Next is 31. It is related to excess pressure. Just now we have discussed what is excess pressure. There is pressure in the liquid drops and so bubbles, which is over the outside atmosphere pressure is called as excess pressure, and it is only because of the surface tension pressures. Then surface tension is 0.05 Newton per meter. Diameter of the bubble is here. Diameter is given here. Diameter is 2 times radius. We require radius. Diameter is 4 centimeters. Radius is 2 centimeters. 2 10 to the power minus 2 meters. What is the excess pressure in the soap bubbles? Soap bubble excess total pressure is nothing but equal to inside is an atmospheric pressure plus this atmospheric pressure plus 40 by R for two surfaces. So excess pressure is excess pressure. Excess pressure is nothing but equal to 40 by R. If it is liquid drop, 2 T by R. 4 into T by R will be the value equal to 10 pascals. Pressure is pascals and Newton per square meters. Next 32 question number. Two liquid drops of diameters R1 and R2. 2 R1 per meter diameter is given. Diameter ratio equal to radius ratio. What are the excess pressures? It is related to the liquid drops. Liquid drops are soap bubbles. Excess pressure is inversely proportional to radius only. So in this case, excess pressure equal to 2 T by R for the liquid drops, but our tension is same. For same liquid drops you are taking, so pressure is inversely proportional to R. dP1 by dP1 by dP2 equal to R2 by R1, which is equal to 2:1. In case if you are taking the one capillary tube or tube, one side you are taking one small bubble, other side you are taking the bigger bubble, and kept in contact. This open. What happens here is which one air will travel from one bubble to other bubble. Which one the pressure is inversely excess pressure inside is inversely proportional to radius. Radius is less means pressure is more. So pressure is more here, pressure is less here. This is a P2, P1. P1 is less than P2. The air will travel from high pressure to low pressure. The result is the air will flow from small bubble to big bubble. How long? Until this perishes. Means this becomes smaller and becomes invisible and breaks. But this one air comes now, bigger comes. As the air goes smaller means still pressure is more. So that it keeps on flowing from one side to another side. In case if you have taken the liquid drops coalescence I will discuss later. If you take the one drop inside the bubble inside the other bubble, inside the pressure because of this, and the total pressure P is equal to single bubble if you want to take it means P equal to P1 plus P2 because of this one pressure, excess pressure, because of this other pressure means delta P equal to delta P1 plus delta P2, which is nothing but equal to 40 by R. So T cancels here. What you get here is R equal to 1 by R1 plus 1 by R2 everything. In case if you take the soap bubbles touching each other, one soap bubble is here, other soap bubble is here. Then what happens here is this one pressure is more than this pressures. Radius is R1, radius is R2. This one pressures into this. The result is that this surface, curved surface is modified. So what is the new surface? New radius of curvature of this curved portion. And here the pressure is P1, P2. So what is the resultant pressure equal to is P2 minus P1, excess pressure. So P equal to 40 by R. So 1 by R is equals to 1 by R2 minus 1 by R1 relation we will take. Next, 32 will finish. 36. So bubbles of radius 3 centimeters and 4 centimeters coalescence means we up. Then you can take the under the external condition is temperature is constant. The resultant radius is nothing but equal to under root of r1 square plus r2 square. You have to take this area equal to this energy equal to this energy. So relations you have to take total energy PV equal to nRT terms. You can take n number of bonds do not change. So n equal to n1 plus n2. That relationship and we'll discuss later. Let's just go through the synopsis. The resultant radius bubble. Two bubbles combine to form a bigger bubble. Coincidence means merging. The resultant radius is nothing but the root of r1 square plus r2 square. One is 3, another one is 4. 3 square plus 4 square is 5 square. 3 4 5 triangle. Remember, you can get the result. This is a 5 cm the resultant radius. Next to 43. Rubber cord is floating on the water surface. Length of the rubber cord is wire. 5 centimeters, 5 to the power minus 2 meters, surface tension is 7.2 to the power minus 4 Newton per meter. To pull the cord out of the surface, so how much force minimum force you have to apply. So cord is on the water surface means thickness negligible you have to take. If the thickness given means this thickness also you need to consider. Thickness negligible means you have to take only the length of the wire where the water is contact with the molecule. So one molecule stick to it. If you want to take it out, molecule does not take it out. The surface in basic definition is force by length. But which length you have to consider? Two sets length you have to consider. But two surface means two lengths. So this L prime becomes equal to 2L. F is equals to, so tension equal to F by 2L electrons. Surface tension is nothing but equal to F by 2L. So F equal to 2L into T. F equal to 2L into T. Substitute the values of this length L and T. You will get the force required is 76.2 micronewtons. Answer is given to 7.2 to the power minus 5 newtons. So instead of this wire, in case you could have given any other shaped wires. For example, if you are given the circular plate is on the liquid surface of radius r. Then what is the minimum force required? Minimum force means actually total force means weight of the wire also you need to consider. So force required to take it out equal to this force F by 2L plus mg F. So if you take the plate means only because surface force is asked, not because of the weight. So if you take the circular plate is in contact with the liquid surface around this L prime becomes equal to 2 pi r F. L prime F by 2 pi r equal to T. F you have to find out. In case you are given the disc with a hole, circular hole, then this radius is R1, this radius is R2. Wherever the molecules are in contact, here also what is liquid is present, here also liquid is present. So here also contact, there also contact. So what is L prime becomes equal to this length here? L prime becomes equal to 2 pi R1 plus 2 pi R2. R1 plus R2. This length circumference, this circumference for circular plates. In case if you are given the square plates in contact with the water surface, if you have the square plate like this, length L, breadth B in the water surface, then what is the force required to take it out? So minimum force is nothing, corresponding length L prime equal to L and L is 2L, B and B, 2B. So this L prime will replace with the 2L plus 2B. In case you take the wire, rectangle wire on the water surface, you take the wire, this is a wire on liquid surface. So where you have the contact with the surface is thickness, where negligible if you have taken, then liquid is contact with this and also here inside also L and B. So it will be L, B, B. 4 times you will get 4. 1, 2, 3, 4. 4 times length, 4 times breadth. So wherever L prime is there, that becomes equal to 4 times L plus B inches. To minimum force required to take out that wire. In case if you are taking the hot liquid, temperature increases, surface tension decreases, and at the boiling part of the liquid or at any critical temperature particular part the surface tension is 0. So boiling part of the water at disintegrate, the surface tension of water 1 to 0. Then molecules of the water molecules are converted into gaseous state, means vapors they are converted. So at the critical temperature, the boiling point, water surface tension is 0. As the temperature increases, surface tension decreases, and the water molecule can stick to other materials, and coercive forces decreases. Due to the reason warm water is preferred for washing clothes and taking bath, so that dust particle will be easy to wash away. Similarly, impurities like soap and detergents, they reduce the surface tension of the water. Kerosene added to the surface of kerosene or oils have the low surface tension and so low density float on the water surface. So stagnant water, the mosquitoes lay the eggs on the stagnant water. So mosquitoes will also stand on the water surface because of the surface tension. So if you spray the kerosene oils, then the surface tension is lowered, mosquitoes will sink and then they cannot lay the eggs. Even eggs also sink and then die. Thus mosquito breeding is controlled by spraying the kerosene on the surface of the stagnant water. . Soaps and detergent reduces surface tension and used for the washing clothes. These soap molecules have the two parts. One is called as this has a head and a tail. One is hydrophobic, another one is hydrophilic. This is hydrophilic. Hydro means water. This is hydrophobic. This is hydrophilic. Sometimes two tails means actually there are already molecules formed in the shape, resultant shape we take like this. So any dust particles present in the water, when you are mixing water, soap solution, etc., detergents, even the toothpaste also the detergent. Detergent contains the molecules having the two parts, hydrophobic and hydrophilic. Hydrophobic means not liking, hydrophilic means liking water molecules. So about these dust particles, so these sticks, tails will stick to this dust particles, all directions, and this comes in this cylinder. It's like a ball structure, like a ball structure is formed. All tails stick to this, and along with the water molecules, as you wash away, this whole ball will be washed away. Next question number 44, I wrote the same question from there, from that end. Find the force required to separate the two glass plates with a squeezed liquid drop of area 10 to the power of -2 square meters between them. Liquid that droplet spreading between the two glass plates has a thickness 0.05 millimeters, converted to meters 0.05 10 to the power of -3 meters. So water molecules, if sticking two glass plates of the thickness of the liquid layer is D, then liquid shape will between them is concave surface and sticks the two surfaces. For two surfaces, if you want to separate two sides, you have to apply the forces two sides and separate them. So molecules at surface touching, wherever the surface touching the circular portion, you have to take the area equal to A. Area is nothing but equal to pi r square. Same problem may be given with instead of giving with the data of radius instead of the area of the circular droplets. So water squeeze changes into this shape. What is the force required to separate the glass plates? Work done is nothing but equal to force and displacement. Directly you have to remember this formula. Force required to separate the two glass plates with the liquid squeezed between them, which you can stick to the glass plates, not the mercury. Mercury does not stick to the glass plates. The force required is 280 by D. If it is a single surface, 80 by D, but two surfaces are there, means 280 by D. Wherever area is required, now you have to take the two surfaces. Means 2A you have to take by D. This 2 into area is already given in terms of the square meters, SI units, but D converted to meters. And the surface tension given as for the liquid is 78 to the power of -3 Newton per meter. So the values will get the force required is 28 newtons. And sometimes they will give you only the shape of the liquid. This for the liquid which wet the glass, we take like this. Theta is less than 0. So less than 90 degrees, which is wet the glass, you will get the shape concave shape here. But if it is a mercury graph, if you take the mercury between the two glass plates, it does not stick to the glass plates, but the squeezed, when you squeeze this, mercury takes a convex shape between the glass plates. This is supposed to be mercury between the two glass plates. This is the water which is the two glass plates. The surface you have to identify it. Next question number 50. Mercury drop of radius r equal to 1 centimeter split into 10 to the power of 6 droplets of equal size. The surface of the mercury drop, it is a mercury, surface is very high per mercury, it is 460 to the power of -3 Newton per meter. Energy, what is the energy required to break it? Whenever the drop broken into small droplets, energy is absorbed. In reverse, reverse is called as a coalescence and merging. If the droplets are merged to become bigger drop, they release the energy. Reverse case. These formulas are here. Coalescence means merging of the droplets or drop splitting. If you want to break the drop into droplets of equal sizes, no, you have to supply the energy from outside. Energy absorbed we can take. Energy is absorbed. Due to that energy absorbed, whenever you spray the liquid, water is sprayed into small droplets, that area surrounding atmosphere decreases because water breaks into small droplets by absorbing the surrounding energy. Therefore, the temperature decreases in the surrounding atmosphere. So, drop into small droplets of equal diameter, equal radius smaller, and n drops of droplets, n droplets taken. That surface area, this is 4 pi r square, this surface area is n into 4 pi r square. So, surface area always will be increasing. Total surface area of the droplets will be more than the surface area of the big drop. And already we know the surface tension formula, we know that work by area, change in area to take. This work itself is the energy required, W equal to T into delta A we have to take. And what remains constant here in this case is volume remains constant, whether droplets merging to form a big drop or big drop splitting into droplets. Whenever this merging, energy released, breaking up, energy absorbed. Here volume remains constant, 4 by 3 pi r cube n into 4 by 3 pi r into small r cube. This 4 by 3 pi cancels. The result is r cube to n r cube. You have to remember this relationship. R equal to n to the power 1 by 3 r. This also you have to remember the relation. One you know means other you can easily find out. Area of the bigger sphere is surface area. The surface area of bigger sphere is 4 pi r square. For small sphere for n droplets is n into 4 pi r square. For small area is more bigger than that with the smaller bigger ones. More surface area, more surface energy, which is also potential energy on the surface of the molecules. Work done. Work done W is equals to T into A delta A. Surface is equal to work done by changing area. You take it up. So final minus initial. If you take this final or this minus or plus doesn't matter. I am taking only the magnitude difference. So final area, the smaller droplet is bigger is area you will find compared to the smaller one. Substituting this n into 4 pi r square. The smaller area minus bigger area delta A, you will get the relation. This relation you have to remember, and work done. 4 pi t into n r square minus r square. Or you may be given terms of only smaller radius. Small droplets given means use this formula. And if they give only bigger radius, use this formula. In terms of the bigger drop radius, use this formula. In terms of the small droplet radius, if they given means use this formula. And you are given the both radius and use this formula. So these formulas you need to remember directly to get the problems. And whatever the drop formed, really energy released to form a bigger drop may be converted into kinetic energy or increase in temperature. If they ask you to do kinetic energy means this work done, whatever the formula is there, no, equate equal to half mv square. M is the mass of the droplets. Mass is also equal to volume into density. Density is nothing but equal to mass by volume. Volume itself is 4 by 3 pi into r cube. This is for the bigger droplets I am telling, which is absorbed energy produced converted into kinetic energy or increase in temperature. If they ask in increase in temperature means that the heat produced, the work done equal to heat equal to mass into specific heat into change in temperature. They don't give you the values, they only symbolic form they will ask you. Check up the synopsis for these expressions of kinetic energy, velocity expressions, and also heat produced means temperature difference they will ask you. Mass into specific heat into temperature difference itself is equals to W. You have to take wherever mass is there replaced with 4 by 3 pi r cube in the expressions. But you better remember the equation directly, that is better to save the time. Next, come back to this problem. Here in this case, a big drop splitting into small droplets. Big drop splitting into small droplet means you are already given in before radius. Initial radius capital is given. Capital is how much is 1 centimeters. So capital formula is this one. This we have to use. For W equal to 4 pi t r square. It is a liquid drop in single surface. So bubbles means 2 into 2 area. Wherever area is there, multiply with 2. But here droplets splitting only we take it, not bubble splitting cases. Bubbles merging is there, splitting generally they don't ask. Droplets only will be taken for breaking into droplets. So breaking into droplets or merging. This W equal to 4 pi r square into T into n to the power 1 by 3 minus 1. N is given as 10 to the power of 6 droplets. N equal to 10 to the power of 6, radius of the big drop is 1 centimeter, is 10 to the power of minus 2 meters. So work done formula you have to find out. This work equal to 4 pi r square into T into n to the power of 1 by 3. N is equal to 10 to the power of 6 by 3. 6 by 3 is 2, means 100 it is. 100 minus 1 is 99. The result of calculation is 0.057 joules. Next 51 question. In this reverse of this, here mercury big drop breaking into small droplets, but here what they mentioned is 1000 identical drops combined to form a big drop. Find the ratio of the final surface energy to initial surface energy. They didn't mention bigger radius, they didn't mention smaller radius. Both need to be cancelled, not required here. Initial surface energy is nothing but equal to initial surface energy. There is small droplets it is. So small droplets is surface tension into area. For n droplets, n into A1 you have to take. So that is equals to 4 pi r square. And final surface energy is nothing but equal to, they are combined to form a big drop. Small droplet is combined to form a big drop. So final surface energy is nothing but equal to, that is for the bigger one, is surface tension into area. Coming back to this relationship, your asked is final minus initial means bigger. This is for the bigger one by smaller ones. Bigger one is area is A2 by ratio of these two. If you take no TT cancel, surface tension cancel. So what you get here is A2 big by small. They ask final by initial. A2 by NA1. A2 by NA1. A2 is for the bigger one is 4 pi r square and smaller one is 4 pi small r square. 4 pi cancels. Capital R square by NR square relationship. But what is the R and R relation? R equal to n to the power 1 by 3 into small r. Putting the values into this, r square by r square. R square by r square is n to the power of 1 by 3. So you will get is n to the power of minus 1 by 3. Take it, that comes to the denominator as n to the power 1 by n to the power of 1 by 3. And n is given is equals to 1000. 1000 means 10 to the power of 3 you can write. 10 to the power of 3, 1 by 3 is equals to, but 3 cancels, the result is 1 by 10. The ratio of the energies of the final to initial is 1 by 10. They may ask in reverse also, you check up that. Next relationship. Next general expressions is formula, only formulas based questions they may ask you. You are taking the capillary tubes in the form of a U-shaped tube, not a big tube. Please. Big tube means surface tension effect will not be there. Narrow tubes only you will find the surface tension effects. So if you take the surface tension effects, if it is not surface tension effect, if it is a bigger tube, whatever is the area you take for this or circular diameter you take, thick and thick, the liquid level should be same. Because pressures are equivalent. P1 is equals to P2 is atmospheric pressure only. When pressures are equal, level should be same, please. Whatever is the sizes you take, level should be same. But you are taking the capillary tubes. In the capillary tubes, the adhesive forces, cohesive forces comes into domination picture. In that case, what you take the levels. Narrow tubes have the more liquid riser compared to the wide tubes. In this case, we are taking theta less than 90 degrees. Here for this water, if you are taking means theta is sticking to the glass. If you are taking means theta equal to 0. So surface tension formula, we have the capillary tube method, HRDG by 2 cos theta. So you are taking the H1 is the height in the one tube, H2 is the height in the other tube. The difference in the levels, they will ask the relationship. H1 minus H2 is equals to H. So this H relation you have to express it. H equal to 2T by RdG. So but H1 minus H2 means 2T by dG into 1 by R1 minus 1 by R2 difference you have to get. This formula they ask you directly with the symbols, not with values. Next, one more problem is generally asked, repeatedly asked also in the, not in cassette, other than cassette problems. The sphere is floating in the liquids to the half hemisphere parts. Hemisphere is inside the liquid, remaining hemisphere is in the air. So what is the radius of this sphere, they will ask you. The buoyant force acting upward directions and weight is acting downward directions. I am taking this as a solid, mass of the solid into G is a weight acting downward direction. And surface tension does not let it to sink, so that is also acting upward directions. We can take that is surface tension force, we will take it out. What is the surface tension force? Surface tension is nothing but equal to force by length. So force equal to surface tension to length. So force due to surface tension we take it as equal to T into L. So this T into L, but what is L here? L is equals to 2 pi r, that is the circumference where the liquid molecules are in contact with the solid. So surface tension force is nothing but 2 pi r into T, and weight balance, the weight acting downwards is mass of solid into G, mass equal to volume into density of the solids, 4 by 3 pi r cube into density of solid into G. And buoyant force is acting upwards. What is buoyant force equal to? It is equal to volume of the liquid displaced. Volume is only hemisphere portion you are taking. So we take the mass of the liquid displaced into G, which is half into 4. So hemisphere volume is 4 by 3 pi r cube, but half means hemisphere volume. This is the total volume by 2. Into density of liquid into G is the buoyant force. Next, balanced condition you are taking means this sphere, which is solid sphere I am taking here, the total weight acting downwards equal to surface tension force plus buoyant force, which are acting upwards. Downward force equal to upward force. Putting the values in substitution, you will get the expression for the radius as R equal to 3T by 2 times density of solid minus density of liquid into G. You check up that formula, direct formula. If you remember, it is always better to save the time while doing the problems. With this, I am stopping the surface tension topic.